Sip Nine Hub.
Hi there, welcome to another episode of our series on inferential statistics. In the previous video, I have shown you how to conduct t-test for independent samples, either assuming equal variances and assuming unequal variances. In this presentation, we're going to answer another problem that would require us to use another test.
But before we continue, do not forget to like this video, hit the subscription and notification bell to stay updated of future videos.
Let me read first the problem to you. A graduate student is interested to know whether a particular teaching strategy is effective as an intervention in increasing students' performance in the topic subject-verb agreement. Below are the pre-test and post-test scores of a group of students. Test whether there is a significant change in the scores after applying the strategy, assuming that the datasets passes the normality assumption. The last statement here means that we're going to conduct a parametric test. First, that we're going to identify are our hypotheses, starting off with our null hypothesis. So we are comparing still the mean scores for the two groups, the groups of students under the pre-test and then the post-test. So we may write, alternatively, we can write this statement as the mean scores of students under the pre-test and the post-test are equal. We can also use symbols such as this one. For our alternative hypothesis, it's just a contradiction of our null hypothesis. So we may say the mean scores of students under the pre-test and the post-test are significantly different. We say this because there is no indication in the problem that we are testing at a particular site. What I mean is, if we are testing whether the mean pre-test score is higher than the mean post-test score, then we are actually using inequality symbols such as less than or greater than. But it says here that we're going to test whether there is a significant change. A change is whether it decreased or increased. This also means that we are conducting a two-tailed test. Now, let us identify the appropriate test that would answer the problem. We are comparing two groups, the scores of students during the pre-test and the scores of the students during the post-test. If we look at our data, the two groups are actually termed as related. For each student, there are two corresponding scores because for each of them, we should see the pre-test score and the post-test score, and we do not just encode it in any way, but we need to pair these scores. So we are comparing two groups, but the groups are related. The appropriate test to compare these kinds of groups is called what? If we go back to our list of analysis, so we have to click this one, data, and then data analysis. We have t-test paired to sample for means. This is exactly what we need. So our test is paired. We can simply call it as paired t-test. Let us proceed to the computation. So we go back to data analysis, click t-test paired, and then we have the same looks. We need to input our first and second data set here. So this is our first data set. Hold and drag, click in the second space, input the second data set. We included the labels at the top row of each column, so we need to check labels. Let us make our alpha 0.05. Let us select our output range. I want it here. That's it. We can click OK, and it would give us the result of the analysis. Again, we do not need all of these things. We only need a few. First, we need the means. Let me highlight what we need. The means. What else? Our t-stat. We also need that one. And our probability value. We have a probability value for a one-tailed test. So if we look at it, this means one-tailed test. This is the probability for two-tailed test. But we identified that we are doing two-tailed test. So let us have this. What is this number? 1.56 e negative 11. This is actually a scientific number. This means that 1.5 times or 1.56 times 10 raised to negative 11. This is actually a very small number. If we put this in decimal, so we can change this one. If you notice, we can put this as a number. It becomes 0.00 because this is actually a very small number. 1.56 times 10 raised to negative 11 is like 0.0000, and I don't know how many zeros. That's actually 10 zeros before the numbers 156. And then we have our conclusion. What is our p-value? It's 0.00. This is not exactly 0. Again, I'd like to emphasize that this is just a number that is very small, but it is not equal to 0. It's just a small number. So it is obviously less than 0.05. It is even less than 0.01. Should we accept or reject our null hypothesis? It's really small. It's lower than our critical point for probability values, which is 0.05. So we reject our null hypothesis. So that our null hypothesis should be the true statement. So that the mean scores of students under the pre-test and post-test are significantly different. Again, we transfer what we need. So we do not report everything here if it's a research. We only need a few. Those are the things that I have highlighted. So let me quickly put these values here. Also, let us give descriptive equivalence. Let me do that. For pre-test, it's this score. For post-test, it's this score. Descriptive equivalent, we can manually assign or we can use lookup. Alright, so we see here that we have poor for the mean score during the pre-test and satisfactory for the post-test. For our t-computed, that is the same value as our t-stat, that is positive 14.13. So we just took the absolute value for that, and then the probability value is this value. It's a very small number, but not equal to 0. By convention, if the p-value is not just lower than 0.05, it is also lower than 0.01, then we term that as highly significant. The symbol for that is a double star. There, we can see that in our legend. So what does this result mean? It means that the scores of the students during the pre-test is quite lower, significantly lower than the mean score of the students during the post-test. We might say that the intervention that the teacher used is quite effective, basing only on the means that are significantly different. The post-test scores are significantly higher than the pre-test score. Descriptively, it's obvious. The first one is poor, the other one is satisfactory. Anyway, this problem applies experimental methodology. This is an experimental design. However, this is not a very good design. This is actually a poor design. We cannot just measure the effectiveness of an intervention by doing this one. We cannot just have your students answer a pre-test and then a post-test after, and then just compare the two. This is a very poor experimental design. The conclusions that we have said a while back might be questioned just because of the design that we used and not because the analysis that we conducted. Anyway, the goal here is to show you how to conduct a paired t-test in MS Excel. What do we have here? We have different data but the same problem. So let us just analyze this one. Of course, it's the same problem. So the null hypothesis until the test that we're going to use are just the same. Let us conduct the same test, paired t-test, but a different data. For the first one, enter the first data set. And then another set. Labels are checked. And then specify where you want to put that. Okay. Here are our results. Again, we only need the mean. Let me highlight those things that we need. We need also the t-stat. We need to report that. And then the probability value corresponding to a two-tailed test. Simplify our numbers here. We can round that up to 2 decimal places. Okay, we see here that the mean for the pre-test scores is 85.05. It's actually almost equal to the mean score for the post-test. That is why in our probability value, it's quite high, 0.70. It's really greater than 0.05. That means that the mean scores for the two groups here are not significantly different, or we term them as having equal mean scores. If this is the result, then we are far from concluding that that intervention that the teacher did is effective. In fact, the teacher just wasted his or her time doing this intervention because the students have knowledge by about this percentage, 81.05, and it barely increased after the intervention. That's how we conduct paired t-test in MS Excel. Thank you for listening. In the next videos, I am going to show you how to conduct analysis of variance or ANOVA or even correlations. I will see you there.